Hello students and good afternoon. So now I am doing class for class 12. The topic is second order derivative. So in the last online class also we were doing this same topic, that is second order derivative. So this is your continuation class. So we will do from the same exercise 4. Each question carries 5 marks, page number 322 from the book Higher Mathematics for class 12 by Sailendra. And in the last online class we did 11 number 1. So now we will do 11 number 2. If y square is equal to ax square plus 2bx plus c, then you have to prove that d2x by dy square is equal to b square minus ac whole divided by ax plus b whole cube. Okay, now let us prove it. But you have to prove here d2x by dy square. Okay, so write down given here is, given is y square is equal to ax square plus 2bx plus c. Now let us find out first dy by dx. Let us differentiate both the sides with respect to x. So differentiating both the sides with respect to x. So what is the differentiation of y square with respect to x? It is 2y dy by dx is equal to a is constant. What is the differentiation of x square? It is 2x, so it is 2ax. For 2bx it is only 2b, and for c it is 0. Okay, so let's simplify it further. So 2y into dy by dx is equal to, what is common here? 2 within bracket we have here ax plus b. Here 2 gets cancels, or what is the value for dy by dx? So dy by dx is equal to ax plus b whole divided by y. Okay, so we have got the value for dy by dx, right? Now since you have to get d2x by dy square, let us invert both the sides, because you have to get dx by dy in order to get d2x by dy square, right? So let us invert both the sides. So dx by dy is equal to y upon ax plus b. So I think you have understood it. So now in order to get d2x by dy square, let us differentiate both the sides with respect to y. Okay, so now differentiating both the sides with respect to y. So differentiating both the sides with respect to y. So what do we get? Therefore d square x by dy square is equal to, now you can use your u by v rule, because both are the variables. Y is the variable in the numerator and ax plus b is the variable in the denominator. So let us use u by v rule. So now keeping the denominator as it is, take the differentiation of the numerator with respect to y. So ax plus b is kept as it is into, now differentiate y with respect to y, it is 1, minus y is kept as it is. Now numerator is kept as it is, that is y. Now take the differentiation of the denominator with respect to y. So what is the differentiation of ax plus b with respect to y? So here is constant, a is constant, into, what is the differentiation of x with respect to y? It is dx by dy. So this whole divided by, that is, what is the rule here? Denominator whole square. That is your ax plus b whole square. So I think you have understood it. Okay, so we can put the value for dx by dy here. What is the value for dx by dy? It is y upon ax plus b. Or now it is d2x by dy square is equal to, now ax plus b into 1 is x plus b minus ay into, now let us put the value for dx by dy, which is y upon ax plus b. It is y upon ax plus b, this whole divided by, this is ax plus b whole square. So I think you have understood it. Okay, now let us simplify it. So in the numerator, what's the LCM? In the numerator, take the LCM. So what's the LCM in the numerator? It is x plus b. Okay, so now multiply x plus b by x plus b. What is it? it is ax plus b whole square minus, then it is ay square into, now below denominator, that is in the denominator there is ax plus b whole square. So below this expression there is 1. So when it goes up in the numerator, it becomes upside down. So it is 1 upon, this is your ax plus b whole square. Is that clear to all of you? So this is a simplification. Now let us simplify it again. Or this is your d2x by dy square, which is equal to, in the numerator, ax plus b whole square minus a into, so in order to prove b square minus ac divided by x plus b whole cube, so let us put the value for y square from given. What is the value for y square from given? It is ax square plus 2bx plus c. This whole divided by, you can multiply these two factors, isn't it? So what is this product? It is ax plus b whole cube. Is that understood? So ax plus b into x plus b whole square is ax plus b whole cube. Now you can simplify the numerator, d2x by dy square is equal to, now this is a plus b whole square. What is the formula? A square. What is a square? A square x square plus, what is twice ab? 2abx plus, what is b square here? This is your b square. Now you multiply by a minus a here, minus a into x square minus a square x square minus into plus, minus 2abx minus into plus, minus ac, right? So whole divided by, in the denominator you have to write ax plus b whole cube. Okay, you have understood now? So here you can cancel, a square x square will be cancelled, 2abx will be cancelled, or now it is d2x by dy square, which is equal to, in the numerator there will be b square minus ac. It is b square minus ac whole divided by ax plus b whole cube. So it is proved. So I think you have understood it. Okay, so you can copy it. Now we'll do the next question. So now we will do this question number 13, but before that you have to do this question number 12 homework. Okay, question number 12 will be a homework. I'll give you the hint for this number 12. If y is equal to capital A e to the power mx plus capital B e to the power nx, you have to show that y2 minus within bracket m plus n bracket close into y1 plus mny is equal to 0. So in this case, y1 means dy by dx and y2 is d2y by dx square. So in this case, dy by dx, you have to find out dy by dx as well as d2y by dx square. So x and y are the variables and all other terms are constants in this case. That is, capital A, B, M and N are constant. So in this case, you first find out dy by dx, that will give you the value for y1, and then again differentiate y1 to get the value for d2y by dx square, and put all these values of d2y by dx square, dy by dx including y on the left hand side, and prove this left hand side is equal to 0 as you have done in the previous problems. So this question number 12 is your homework. Okay, now let's do question number 13 now. In question number 13, what is given here? If x root under 1 plus y root under 1 plus x is equal to 0, you have to prove that, number 1, you have to prove the first order derivative, that is dy by dx is equal to minus 1 upon 1 plus x whole square, and number 2, you have to prove d2y by dx square is equal to 2 upon 1 plus x whole cube, right? So given here is x root under 1 plus y root under 1 plus x is equal to 0, and you have to prove, but in case of proof, you don't have square root sign here. You have to prove dy by dx is equal to minus 1 upon 1 plus x whole square. This does not contain square root. And in this case also, you have to prove d2y by dx square is equal to 2 upon 1 plus x whole cube. That means you have to remove square root. From given, you have to remove the square root. Now, since you have to prove dy by dx in terms of x and d2y by dx square in terms of x, you have to express y in terms of x from given, eliminating square root. So, eliminating square root from given, you have to express y in terms of x in order to prove these values of dy by dx as well as d2y by dx square. Is that clear? So, write down, given here is x root under 1 plus y root under 1 plus x, which is equal to 0. Now take one of the terms to the right hand side. You take one of the terms to the right hand side in order to square both the sides, and you can remove square root. So, or this is x root over 1 plus y is equal to minus y root over 1 plus x. Is that clear? Now you can remove square root from both the sides by squaring both the sides. Okay? So, squaring both the sides. So, squaring both the sides. So, what do we get? Therefore, x square within bracket 1 plus y. X square, and square root will be removed. That is within bracket 1 plus y is equal to, this is minus, whole square is plus. So this is y square within bracket 1 plus x. So now let us simplify it further. Or x square into 1 is x square plus x square y, which is equal to, on the right hand side, y square into 1 is y square plus y square x. Y square into x is y square x. So I think you have understood it. Now x square y square term, this is x square term, this is y square term. Let us keep them on one side, and this y square x term and x square y term, let us keep them on the other side. Okay, so x square y square, take to the left hand side, it becomes minus y square, which is equal to, on the right hand side, what do we write? It is y square x square y, take it to the right hand side, it becomes minus x square y. So I think you have understood it. Okay, so, or what is x square minus y square? This is your a square minus b square, which is a plus b into a minus b. So this one is x plus y into x minus y is equal to, so on the right hand side you can take common out here. So what is to be taken common? So what is to be taken as common here? Minus xy. So within bracket you write first positive term, minus to minus plus. So this is x, y is there, so minus to plus is minus. Since xy is taken common here, so it is y. Is that clear? So from both the sides you cancel this x minus y, right? So, or x plus y is equal to minus xy. X plus y is equal to minus xy. So I think you have understood it. Okay, so now let us express y as a function of x. Let us get the value of y in terms of x. So, or, so y minus xy, take it to the left hand side, becomes plus xy is equal to minus x. So x is taken to the right hand side, so it is minus x. So what is common out here? Y within bracket 1 plus x, which is equal to minus x. So what is the value for y here now? So, or, so what is the value for y? Y is equal to minus x divided by 1 plus x. So we have expressed y as a function of x. Is that clear to all of you? So now let us differentiate both the sides with respect to x in order to prove the value for dy by dx as well as d2y by dx square. So differentiating both the sides with respect to x. So it is dy by dx is equal to minus sign. So within third bracket, You can use u by v rule here. You know u by v rule, isn't it? So 1 plus x, denominator is kept as it is. 1 plus x is kept as it is into, take the differentiation of the numerator. What is the differentiation of x? With respect to x, it is 1. Then comes minus sign. Keep the numerator as it is into, take the differentiation of the denominator. What is this differentiation? What is the differentiation of 1 plus x? It is 0 plus 1 into 1 whole divided by, this is 1 plus x whole square. So you have understood this u by v rule, okay? So you can copy it. Now we will simplify it now. So let us simplify it. Or dy by dx, or dy by dx is equal to, in the numerator, this is minus sign. What is there in the numerator? Multiply it. 1 plus x into 1. This is 1 plus x, and then minus x whole divided by 1 plus x whole square. So here x gets cancels. So, or what is the value for dy by dx? Which is equal to minus 1 upon 1 plus x whole square. So we have proved the first part. So first part is done, proved. Okay. So again you have to prove the value for d2y by dx square. Again you have to differentiate both the sides with respect to x. But in this case, if you differentiate both the sides with respect to x, you don't have to use u by v rule on the right hand side, because numerator is constant, only the variable is in the denominator. So in this case you don't have to use u by v rule. So in this case you can take the denominator to the numerator. So it is dy by dx is equal to minus 1 plus x whole to the power minus 2. So before differentiation, you have to simplify the right hand side. You take denominator to the numerator. So it becomes 1 plus x whole to the power minus 2. Now let us differentiate again both the sides with respect to x. So again differentiating both the sides. Again differentiating both the sides with respect to x. So what do we get? Therefore d2y by dx square is equal to, now this is in the form x to the power n. 1 plus x is the variable. Take it as x. What is the differentiation of x to the power n? N into x to the power n minus 1. So here minus 2 comes in the front. Minus 2 into minus plus 2. Then x here is 1 plus x whole to the power. Decrease the power by 1. That is your minus 3 into, again you have to differentiate the term which is assumed as x. That is 1 plus x is also to be differentiated with respect to x. So what is the differentiation of 1 plus x? It is 0 plus 1. So into 1 is here. Or d2y by dx square is equal to, you can take this term 1 plus x whole to the power minus 3 in the denominator. So it becomes 2 divided by, what is 1 plus x whole to the power minus 3 in the denominator? It is 1 plus x whole cube. So it is proved. That is number 2 is also proved. You have understood now? So this is the answer. So this question number 12 is your homework. Okay. Now we'll do the next question. So now we'll do the next question, that is question number 14. If y is equal to e to the power m sine inverse x, find the value of y2 within bracket, then 0 is given here. So what is the meaning of y2 within bracket? 0 is out here. This means that you have to get the value for y2 when x is equal to 0. You have to get the value for y2 when x is equal to 0. Is that clear? You have to find out the value for y2 or d2y by dx square when x is equal to 0. That means you have to differentiate these both the sides with respect to x. That is, first of all you get dy by dx, then again differentiate dy by dx to get d2y by dx square. Okay. So given here is y is equal to e to the power m sine inverse x, right? So differentiating both the sides with respect to x. So differentiating both the sides with respect to x. So what do we get? Therefore, it is dy by dx. You can directly differentiate it because here sine inverse x is the variable. You can take it as e to the power x. Here m is constant. So it can be taken as e to the power x. What is the differentiation of e to the power x? It is e to the power x. Here x is m sine inverse x. Now this m sine inverse x is taken as x. That is differentiation of e to the power x is e to the power x. Again, you have to differentiate the term which is assumed as x. So in this case, m sine inverse x is assumed as x. So what is this differentiation? It is into m into, what is the differentiation of m sine inverse x? It is m into, what is the differentiation of sine inverse x? It is 1 upon root over 1 minus x square. So is that clear to all of you? So I think you have understood it. Okay. So now what will you do now? So again you have to differentiate both the sides with respect to x. But before that you simplify it. Now cross multiply by root over 1 minus x square into dy by dx, which is equal to, here you will write m first, into, what is e to the power m sine inverse x? What is e to the power m sine inverse x? It is y. So it is my. Is that clear to all of you? So instead of e to the power m sine inverse x, you have to write y here. So I think you have understood it. Okay. So now here you can differentiate both the sides with respect to x. Before that you remove square root. So how can you remove square root? Squaring both the sides. Okay. So squaring both the sides. Squaring both the sides. So what do we get? Therefore 1 minus x square. Here root over 1 minus x square whole square is, root over will be removed. So it is 1 minus x square only into dy by dx whole square. Dy by dx whole square. Right? Which is equal to, now right hand side also you can square the right hand side also, that is, it is m square y square. So I think you have understood it. Now you can differentiate both the sides with respect to x. So again differentiating both the sides. Again differentiating both the sides with respect to x. Okay. So on the left hand side you can use UV rule because these are the product of two functions. Now keeping the first term as it is, therefore 1 minus x square into, take the differentiation of dy by dx whole square. So it is in the form x square. What is the differentiation of x square? It is 2x. 2 into dy by dx into. Now again differentiate the function which is termed as x. That is dy by dx लाई हामीले x सम्झेको, त्यसलाई फेरि डिफरेन्शिएट गर्दा कति हुन्छ? d2y by dx square. Is that clear? Next plus now this dy by dx whole square is kept as it is now. Take the differentiation of the first function. What is the differentiation of 1 minus x square? It is 0 minus 2x. That is minus 2x. Plus को जग्गामा minus लेख्नु किनभने plus into minus is minus. So it is minus 2x into dy by dx whole square into dy by dx whole square, right? So here dy by dx whole square is kept as it is, and we have taken the differentiation of 1 minus x square, so which is minus 2x. So which is equal to m square is kept as it is into, now what is the differentiation of y square with respect to x? 2y into dy by dx. 2y into dy by dx. Is that clear to all of you? So I think you have understood it. Now you can simplify it further. So you can take common here. Dy by dx whole square means dy by dx into dy by dx. So here 2 into dy by dx is taken common. So or 2 into dy by dx within second bracket 1 minus x square into d2y by dx square, right? Minus sign. Now here 2 is taken common. one of these dy by dx is also taken common, so it is minus x into dy by dx, x into dy by dx, second bracket is closed. So which is equal to m square into 2y into dy by dx. So I think you have understood it. Okay, so here you can cancel these 2 gets cancels, and also dy by dx will be cancelled, right? So or what do we get now? 1 minus x square into d2y by dx square. Okay, then minus x dy by dx, which is equal to, this is your m square y. So we have got this relation. Okay, but in the question this relation is not asked, but you have to get the value for y2 when x is equal to 0. But you have to get the value for y2 when x is equal to 0. Okay, but in this case we have got the value for y also. We have got this relation in terms of y also. So from given you have to get the value for y when x is equal to 0. Okay, so now again you have to get the value for y when x is equal to 0. This y2 within bracket, this 0 means x is equal to 0. So given here is, in given y is equal to e to the power m sine inverse x. So if you put x is equal to 0 here, what is the value for y? You have to find it. Okay, so putting x is equal to 0. So putting x is equal to 0, y is equal to e to the power m sine inverse, this is 0, right? So sine inverse, this 0 is there. Sine of which angle is 0? Sine 0. So therefore y is equal to e to the power m sine inverse, this is your sine 0, right? Or y is equal to e to the power m into, what is sine inverse sine 0? You know inverse circle function, that is 0. So or y is equal to e to the power m to 0 is 0, e to the power 0 is always 1. So y is equal to 1. So when x is equal to 0, what is the value for y? 1. So when x is equal to 0, what is the value for y? It is 1. So we will put these values in this relation in order to get the value for y2 within bracket 0. Okay, so now write down this relation again 1 minus x square d2y by dx square, right, minus x dy by dx minus x dy by dx is equal to m square y, is equal to m square y. Is that clear now? So we can put x is equal to 0 here now. Putting x is equal to 0 and y is equal to 1. Okay, so therefore 1 minus 0 square into, this is your d2y by dx square, minus again what is x? 0. 0 into dy by dx, which is equal to m square into 1. That is the value for y is 1, right? So or this is 1 minus 0, which is 1. So it is d2y by dx square minus 0 into dy by dx, that is 0, which is equal to m square into 1 is m square. So we have got the value for d2y by dx square, which is equal to m square. Okay, but what is y2 here? You can write it as y2 within bracket, then here you write 0. This means x is equal to 0. So which is equal to, what is this value? It is m square. So this is the final answer. So I think you have understood it. So you can copy it. Now we'll do the next question now. So now we'll do the next question, that is, this question is from worked out example from the book. Okay, so this question is from the worked out example from the book. Okay, so this question is very, very important. You can mark it. If x is equal to sine t, y is equal to sine kt. So in this case, x and y are expressed in terms of a third variable t. T is a parameter here. So this is a parameter equation. and here k is a constant. Okay, then you have to prove that 1 minus x square d2y by dx square minus x dy by dx plus k square y is equal to 0. You have to prove this relation in terms of first order derivative and second order derivative. Okay, so let us find out dy by dx from this given parametric equation. So in this case k is a constant. Okay, now solution. So here given x is equal to sine t. Now differentiating both the sides with respect to t, differentiating both the sides with respect to t. So therefore dx by dt is equal to cos t. Let us mark it number 1. Again y is equal to sine kt, right? So differentiating both the sides with respect to t, differentiating both the sides with respect to t. So this is your dy by dt is equal to cos kt into, again differentiate kt with respect to t, which is k, or this is your dy by dt is equal to k into cos kt. So let us mark it as number 2. So now what will you do with this 1 and 2? What will you do with this 1 and 2? You can divide it in order to get the value for dy by dx. So dividing 2 by 1, in order to get dy by dx, what will you do with this 1 and 2? You have to divide 2 by 1. Okay, so dividing 2 by 1. So dividing 2 by 1. So what do we get dividing 2 by 1? dy by dt divided by dx by dt, which is equal to, on the right hand side, k cos kt divided by, what is dx by dt? It is cos t. Is that clear now? So from the left hand side you can cancel this dt and you will get dy by dx, which is equal to k cos kt divided by cos t. Is that understood now? So what will you do in the next step? So before differentiation, let us simplify the right hand side. So on the right hand side there is cos kt divided by cos t. So if you can convert cos t into sin kt, you can write y, and cos t, if you can write it in terms of sin t, then for sin t you can write x. Okay, so or this is your dy by dx, which is equal to k. What is cos kt in terms of sin kt? It is root over 1 minus sin square kt divided by, in the denominator also similarly, what is cos t in terms of sin t? It is root over 1 minus sin square t. So I think you have understood it. So why are we converting cos kt and cos t in terms of sin? Because you may put the value for sin kt as y and sin t as x. Okay, so or it is dy by dx is equal to k root over 1 minus, what is sin kt? It is y. This is your y square divided by root over 1 minus, what is sin square t? It is x square. It is x square. So I think you have understood it. Okay. Now before differentiation, you do cross multiplication. You do cross multiplication here, or this is your root over 1 minus x square into dy by dx into dy by dx, which is equal to k into root over 1 minus y square, k into root over 1 minus y square. Okay, so now you can remove square root from both the sides. So how can you remove square root from both the sides? You have to square both the sides. So squaring both the sides, squaring both the sides. So what do we get squaring both the sides? 1 minus x square into dy by dx whole square, which is equal to k square into, this is your 1 minus y square. from both the sides, square root is eliminated by squaring both the sides. Okay. So now what will you do in the next step? So in the next step, you have to differentiate both the sides with respect to x in order to prove the required relation. Okay. Now again differentiating both the sides with respect to x. So, or this is UV rule. You can use UV rule here. 1 minus x square into, what is the differentiation of dy by dx whole square? It is 2 into dy by dx into d2y by dx square plus. Now again dy by dx whole square is kept as it is. Take the differentiation of 1 minus x square. What is it? Plus into minus is minus. For 1 it is 0. Plus into minus is minus. What is the differentiation of x square? 2x. Now dy by dx whole square is kept as it is. Okay. So is equal to k square into, within bracket, k square is constant. It is kept as it is. Now differentiate 1 minus y square with respect to x. For 1 it is 0 and for y square it is minus 2y into dy by dx. So I think you have understood it. Okay. Now let's simplify it. Now on the left hand side you can take common here. So you can take common from the left hand side. What is common from the left hand side? It is 2 into dy by dx. So within second bracket, what do we get? 1 minus x square. 1 minus x square into d2y by dx square. d2y by dx square. Okay. Then minus sign is there. Minus 2 dy by dx is taken common. So it is minus x into one of these dy by dx is taken common. So there remains dy by dx. Second bracket is closed. So which is equal to plus into minus k square into 2 dy by dx. K square into 2y dy by dx. That is minus k square, then 2y dy by dx. From both the sides you can cancel 2 dy by dx, as this 2 dy by dx not equal to 0. Since 2 dy by dx not equal to 0, so you can cancel them. So what do we get? 1 minus x square. This is d2y by dx square minus x dy by dx, which is equal to minus k square y. Is that clear? So minus k square y, you can take it to the left hand side now in order to prove this required relation. So, or this is your 1 minus x square into d2y by dx square minus x into dy by dx plus k square y, which is equal to 0. So that is required relation is proved. So we have proved the required relation. So you can copy it. So now we'll do the next question. So now we'll do this question, that is, this question is also from worked out examples from the book. So if it is given that y is equal to x to the power n minus 1 log x, you have to prove that x square d2y by dx square plus within bracket 3 minus 2n bracket close x into dy by dx plus n minus 1 whole square y is equal to 0. From the given relation, you have to prove this required relation. So here given is, let us solve it now. Given y is equal to x to the power n minus 1 into log x. Now let us differentiate both the sides with respect to x. So differentiating both the sides with respect to x. Okay, so left hand side now becomes dy by dx is equal to, you can use UV rule here. Now you can use UV rule here in this case. Okay, so you first differentiate x to the power n minus 1 keeping log x as it is. So take the differentiation of x to the power n minus 1. N minus 1 becomes the coefficient, x to the power decrease the power by 1, that is n minus 2. Then log x is kept as it is. Then plus what do we write? X to the power n minus 1 into, it is kept as it is. Take the differentiation of log x, it is 1 upon x. Okay, now you have to simplify it again before differentiation. Okay, so now if you write here x to the power n minus 1 into log x, you may write instead of x to the power n minus 1 log x as y, isn't it? So you can make it x to the power n minus 1 into x to the power minus 1, right? So here you write dy by dx is equal to n minus 1 into x to the power n minus 1 into x to the power minus 1. If you write this one, if you multiply them, powers will be added, you will get the same expression x to the power n minus 2, isn't it? So why are we writing x to the power n minus 1? Because instead of x to the power n minus 1 log x, you may write y here. Okay, so that means we are breaking this term x to the power n minus 2 as x to the power n minus 1 into x to the power minus 1 into log x. Plus this is your x to the power n minus 1 into 1 by x. Is that understood now? So now, or dy by dx is equal to n minus 1 into, now instead of x to the power n minus 1 into log x, what can you write? Y. Now x to the power minus 1, take it to the denominator, so it becomes x. Is that understood? So here we have simplified this x to the power n minus 2 as x to the power n minus 1 into x to the power minus 1. So why are we writing this x to the power n minus 1 into x to the power minus 1? Because instead of x to the power n minus 1 into log x, we can write y here. And this x to the power minus 1, you can simplify it as 1 by x. Is that clear now? So next, plus x to the power n minus 1 divided by x. Now take the LCM. What is the LCM on the right hand side? It is x. Cross multiply. What do we get? X into dy by dx is equal to n minus 1 into y plus x to the power n minus 1. This is your n, right? This is your n. So now before differentiation, take the term containing y on the left hand side. Okay, so n minus 1 into y लाई चाहिँ हामी केमा लान्छौं? Left side मा लान्छौं. Or x into dy by dx minus n minus 1 into y is equal to x to the power n minus 1. So let us mark it number 1. Is that clear? Now again differentiate both the sides with respect to x. So why are we marking it as 1? Because we may use the value of x to the power n minus 1 in this case, right? So differentiating both the sides, with respect to x. Okay, now here you can use UV rule because this is the product of two functions. Therefore x is kept as it is, d2y by dx square, plus next keeping dy by dx as it is, take the differentiation of x with respect to x, which is 1. So dy by dx is kept as it is, plus next, it is minus sign, minus n minus 1 is constant, it is kept as it is. Take the differentiation of y with respect to x, that is dy by dx is equal to, now on the right hand side, what is the differentiation of x to the power n minus 1? It is n minus 1 into n minus 1 comes in the front, x to the power n minus 2. It is just like your x to the power n, which is n into x to the power n minus 1. So I think you have understood it. So now again x to the power n minus 2, you can make it x to the power n minus 1, so that we can put the value for x to the power n minus 1 from 1. Okay, so or this is x into d2y by dx square plus, here dy by dx is common, so within bracket what do we have? Here dy by dx is taken common, we have within bracket 1 minus n minus to minus plus 1 into dy by dx, which is equal to, on the right hand side, we can make it n minus 1 into x to the power n minus 1 divided by x. Is that understood? So x to the power n minus 2, we can write it as x to the power n minus 1 into x to the power minus 1. So it is x to the power n minus 2, and that x to the power minus 1 becomes 1 upon x. Is that clear? X to the power n minus 2 लाई हामीले कसरी लेखेको हो? X to the power n minus 1 into x to the power minus 1, and x to the power minus 1 becomes 1 by x. Okay, so that we can put the value for x to the power n minus 1 from here. Is that clear? So you can copy it. So now what will you do in the next step? So we can do cross multiplication here, cross multiply by x here. So x into x, x square d2y by dx square plus. So next you have to cross multiply by x. For the second term also it is 1 plus 1, 2 minus n into x dy by dx, which is equal to n minus 1. Now within second bracket, what is the value for x to the power n minus 1 from 1? It is, what is the value for x to the power n minus 1? It is x dy by dx. Let us put it here, x into dy by dx, then minus n minus 1 into y, minus n minus 1 into y. Here second bracket is closed. So I think you have understood it. Okay, so or x square into d2y by dx square plus 2 minus n into x into dy by dx is equal to, now you can multiply here. Okay, n minus 1 multiply garne. So what do we get? N minus 1 into x dy by dx. Is that clear? Then minus, then there is minus sign, n minus 1 into n minus 1. This is n minus 1 whole square into y. Is that clear? That is, the expression within second bracket is multiplied by n minus 1, and we got this expression n minus 1 into x dy by dx minus n minus 1 whole square into y. Now you take all the terms to the left hand side, making right hand side 0. So or this is x square d2y by dx square plus 2 minus n into x dy by dx. Okay, so next, now above n minus 1 into x dy by dx, take it to the left hand side, so it becomes minus n minus 1 into x dy by dx, and then minus n minus 1 whole square into y. Take it to the left hand side. What does it become? Plus n minus 1 whole square y is equal to 0. Is that clear now? So all the terms on the right hand side, they are taken to the left hand side, making right hand side 0. So now let's simplify it. X square d2y by dx square plus within second bracket. Now what is common here? X dy by dx. So within bracket what do we get? 2 minus n, isn't it? Then minus n, minus into minus, plus 1, bracket closed. Because of this minus sign, this becomes plus, minus n, minus into minus, plus 1. Then write x dy by dx plus n minus 1 whole square y, which is equal to 0. Is that clear? Next, or x square d2y by dx square, this is your y, plus within bracket 2 plus 1 is 3, minus n minus 2n into x dy by dx, x dy by dx plus n minus 1 whole square y, which is equal to 0. So is it proved? You can compare it with this one. X square d2y by dx square plus 3 minus 2n x dy by dx, x dy by dx plus n minus 1 whole square y, n minus 1 whole square y, which is equal to 0. So it is proved. So I think you have understood it. So it is proved. So you can copy it. So this much is for today. त आज पनि हामीले जति पनि प्रब्लम्सहरु गर्नु यो सबै घरमा रिभिजन गर्नु। त तिमीहरुको होमवर्क हो यो रिभिजन है। तिमीले घरमा राम्रोसँग प्र्याक्टिस गर्नु यिनीहरु। The next class ma chai we have almost we have almost completed the questions from the book. So in the next class, in the next online class, we will do problems from HS question papers. Okay, so this much is for today. So you can copy it.